The problem statement from GATE Physics 2012 reads as follows. A rod of proper length L0 oriented parallel to x-axis moves with speed 2c by 3 along the x-axis in the S frame, where c is the speed of light in free space. The observer is also moving along the x-axis with a speed c by 2 with respect to S frame. The length of rod as measured by the observer is. This is a multiple choice question with only one correct answer, and we are given 4 options. We are required to find the correct answer. Let's first have a quick look at the theoretical understanding of length contraction. So here on the left you have the frame S, which we call the rest frame or the lab frame. That depends. There are different nomenclatures used for it. So an observer is sitting at origin O here. So what this will do is that this observer will measure. So let's say there is a rod, let's say AB is its length, and its coordinates are correspondingly x1 and t1, and here it's x2 and t2. Okay, so observed length would be, so what is the definition of observed length? Observed length, first of all, observer will measure it and it will measure the length simultaneously, which means when t2 should be equal to t1, and then whatever is the difference of the space coordinates, that would be the length. So this is the definition of observed length, and such events which happen at the same time are called simultaneous events. Okay, what's happening in the picture so, and we also assume that this rod is moving at speed v in this frame. So now we go into S prime frame, which is the rod's frame, So here we denoted this by, let's say, A prime and B prime, right? And here in the S frame this length was L. Here this length is L0. So the coordinates here will accordingly change. This will be x1 prime, t1 prime, while for B prime it will be x2 prime and t2 prime. And obviously this, in this frame, the rod is at rest because this S prime is already moving at a speed v. This will appear at rest, right? And hence, because this rod will appear at rest, whatever length is measured, which is x2 prime minus x1 prime, is called the proper length. Proper length is measured, I repeat, proper length is measured in the frame of reference of the object itself. So object has to be at rest, then only you will be able to measure the length. So here it's the L0, which is simply, you can say, x2 prime minus x1 prime. Now, so if this is known, now what we need to do is we need to find L0 in terms of L. So this is the information that we already know, and we need to link it to the L0 here. So how do we link it? It's fairly simple. We use the Lorentz transformation. So how do we do it? We can do x2 prime, we can note it in terms of x2 and t2. Similarly, x1 prime can be written in terms of x1 and t1, and we'll put it here. So I'll do that. So I can write, so this will be equal to x2 prime will be gamma. I'm using this formula, by the way. So this will be gamma x2 minus v t2 minus gamma x1 minus v t1. So this will come out to be gamma x2 minus x1 minus v gamma t2 minus t1. The t2 minus t1 is 0 because these were simultaneous events. So this term gets vanished. It will remain gamma x2 minus x1. Now I'll write it here. So L0 equal to gamma x2 minus x1 is nothing but L. So L0 equal to gamma L. Now, or alternatively we can say L equal to L0 by gamma. There are two different ways of seeing it, but the thing is, so L0 is the proper length and L is the observed length. So we know gamma will always be greater than 1 when we are talking about relativistic speeds. So length measured in this frame, the rest frame, will always be lesser as compared to the proper length. So it appears that when the objects are moving at close to speed of light, their length shrinks, their length contracts, because L will be less than L0. Hence, that's why this phenomena is known as length contraction. And this is the formula mathematically that you have to recall, and we have talked about the conceptual understanding here. Right. So coming back to the problem that were given to us, before we start solving the problem, it's a good practice for any problem of special theory of relativity to have some pre-checks. The pre-checks are that whether all the frames are inertial or not. So in the question we were given some frame S, where some observer is there which is moving at some velocity, and a rod is there which is moving at some velocity. So this frame S is at rest. We'll assume it to be at rest. So if it's at rest, the velocity is 0. This means S is inertial. That's good. Let's talk about the second frame, which is the observer's frame, because we need to find length of rod as measured by observer. So we need to draw the observer's frames. Let's call this frame S prime, or we can say P's frame, right? So here this will be moving at a speed. So what is it? Is moving at a speed of c by 2 because observer was moving at speed c by 2. So again, S prime is also at constant speed. So S prime is also inertial. S prime is inertial. And consequently, we can draw another frame, which is S double prime, which is the rod's frame. The rod's frame, because we are talking about proper length. So to evaluate proper length, we need to also draw the rod's frame. This is the S double prime, and we know that the rod speed was 2c by 3. So we can see that V rod I'm writing here as 2c by 3. So this is also constant velocity. So we can say S double prime is also inertial. So all the three frames are inertial. This means we can apply our understanding of Lorentz transformation and what are the mathematical understanding of formula that we have. Now, so what are the moving frames? So here the moving frame, you are only concerned about the observer. We can also take about the rod frame, but it's not required per se to solve the problem itself. The moving frame will restrict to P's frame, which is the S prime frame. So what is the speed? We know that the speed is c by 2. What is the direction? Direction is question, it says it's in the x-axis, so it's the I cap. So V by C by 2 I cap. Number of dimensions, here we mean that how many space dimensions we need to use. So the question is only talking about x-axis with no comment on y and z axis. So we'll simply assume it's a 1D system, very simple system, and that dimension is the x dimension, where this is the positive x direction. So these are the things these are the pre-checks that we went through. Right, so now let's just, whatever the problem was given, let's draw some schematics according to that. So in the blue we have the rest frame, which we denote by the frame S, and observer sitting at origin O. So this observer O sees an observer P in red moving at speed 0.5 c in the positive x direction. So now let's draw the frame of reference of P. So this is the frame of P, which is denoted by S prime, and this frame is moving at 0.5 c with respect to the frame S, which makes sense because this observer was itself moving at 0.5 c, and naturally the observer P, which will denote as P prime here, will appear at rest because we are in the frame of P. Now kindly note that there was another object, namely the rod, which is shown in green, which is moving at 2c by 3 in positive x direction. We denote this rod by AB. So this is the frame F. This was given in the problem. It's moving at 2c by 3 in positive x direction. And the same rod will be observed in this S prime frame, that is the particle P will also observe this rod moving. So let's assume that as per S prime frame, the rod's coordinates are now A prime and B prime, and correspondingly the speed will also change to ux prime. Note, speed was ux in S frame, and everything is primed in S prime frame, right? As I told you, there is one more frame which is called the rod's frame. So if you go into the rod's frame denoted by S double prime, so here an observer is sitting at O double prime. Here whatever length is measured by this observer O double prime, this will be proper length because the rod is at rest here. The proper length equal to L naught only in S double prime frame, not in S prime frame, not in S frame. The proper, if you want to measure proper length, you have to go to rod's frame, which is the green frame over here. So let's also label some different lengths. So whatever length we are measuring, whatever length is being measured by this O prime observer, we will call this L prime, and the rod length AB measured by this observer O, we call this L. So there are three different lengths, but L naught will only be measured in rod's frame, which we denote by the frame S double prime, right? So the problem asks is to find the length of rod as measured by P. So this means we first need to go into the frame of reference of P, that is we need to go into the frame of reference of S prime. So we can see that we are here, so S prime, this is frame, that is in frame S prime, and essentially we need to find this entity L prime. Now how do we find L prime when L naught is known? L naught is given in the problem, so it's fairly straightforward problem. We apply the formula of length contraction, which is observed length equal to proper length over gamma, right? So what is the observed length? So observed length is L prime. Note, we are only interested in this frame, right? So I'll write it, L prime equal to proper length is L naught over gamma, right? So now the problem arises, what gamma should we take? So gamma, note, everything has to be with respect to this frame. So we know gamma is 1 over square root of 1 minus the speed of object. That is, which object are we talking about? We are talking about this rod here, a rod over c square. So what I mean to say is that the speed that we see in the formula, this is nothing but speed of object with respect to frame. Okay, so the object here is this green rod because we are interested in measuring the length of the rod, sorry, green object, green rod, and the frame which we are interested in, S prime. So we need to find the speed of object with respect to frame S prime, which we have denoted by the entity ux prime. Now the problem is we also don't know what is ux prime, but we know ux. So we can calculate ux prime if we are given ux by using the velocity transformation, which is given by the formula here. So ux prime we need, so this will be given by ux minus v over 1 minus ux into v over c square. So the value of ux is given to us, which is 2c by 3 over the velocity of v is given as 0.5 c, let's call this c by 2, over 1 minus 2c by 3 into c by 2 into 1 over c square. So this will come out to be, if I take the LCM, this will be 6, so 4 minus 3, this will come out, numerator will come out to be c by 6 over, so this 2 gets cancelled and it will be, so 1 minus 1 by 3, so this will be 2 by 3. Okay, so again if I cancel it, this comes out to be c by 4 plus c by 4. So we have obtained the velocity of rod in S prime frame is c by 4. Now we just need to find the value of gamma, so I'll try to find the value of gamma over here. So that's 1 over 1 minus c by 4 whole squared over c squared. Let me go to the next slide. Okay, so what we need is, so we know L prime, which we need to find is L naught over gamma, right? And gamma we know is 1 over 1 minus c by 4 whole squared over c squared, right? So this will come out to be 1 minus square root of 1 minus 1 over 16. This will come out to be 4 over 16 minus 1 is 15, so 4 over root 15, and I put this value over here. So this will come out to be root 15 over 4 times L naught. So let me now fetch my calculator. So root 15 will be 3.87 divided by 4 is 0.968. So this entity is coming out to be 0.968 times L naught. Yeah, so option D, if you round it off to 2 decimal places, we can write it 0.97 L naught, and which exactly matches with the option D. So that will be a correct answer over here. The key thing to note is that that L naught is in the proper length L naught is in the rod's frame, not in the observer's frame, which is the S prime frame which we talked about here, right? So that's the key thing, and that's all. Option D is the correct one. Thank you for listening.